video, we will study the different elements of a generalized measurement system. So let us start with our topic. A measurement system, it is defined as the schematic arrangement for the measurement or determination of an unknown quantity and analysis of instrumentation. We know that the measurement system, it is going to measure an unknown quantity. So the measurement system or the complete system, it is the arrangement of all the components or all the instruments which are used for the measurement of an unknown quantity, or we can say the analysis of a instrumentation. Okay. So every measurement system, it will consist of different functional elements, and each functional element will perform some specific function, and each functional element, we can say, it will composed of one or more components which together perform the particular function. So completely a measurement system, it is measuring the unknown quantity, or it is performing some type of measurement, and the measurement system, it will consist of different functional . So if we want to study the operation of a measurement system, we will study the functions or the operation of the functional elements. Okay, so operation is defined or explained in terms of the activity of the functional elements, and as I've said that functional elements, they consist of one or more distinct components which performed a specific or a required function in the measurement. So here we are studying the different elements of a generalized measurement system. So if we talk about a generalized measurement system, it will have different functional elements. Let us first draw the block diagram of a generalized measurement system. So it is the block diagram of a generalized measurement system. Measurement system, it is performing the measurement of the unknown quantity. So the input to the measurement system will be the quantity which we want to measure, and that unknown quantity is called the measurand. Okay, so input is the measurand. This input is supplied to the first functional element of the measurement system, that is the primary sensing element. This primary sensing element, it senses it measures the measurand, and then it gives its output to the variable conversion element, which is the second functional element. Then we have the variable manipulation element, which manipulates the variable Then we have the data transmission element, which transmit the data between the different components of the measurement system. Then either this output of data transmission element will be given to the data presentation element, or it is given to the data processing element. After processing, it is given again to the data presentation element, and then the observer, it reads the value of the measured variable. So this is how a generalized measurement system can be represented. So in this we have different functional elements. So let us study each of the functional element in detail. First we will start with the primary sensing element. So primary sensing element is the element which is sensitive to the measured variable. So the quantity which we want to measure, that is the measurand, it makes its first contact with the primary sensing element. So primary sensing element, it is going to sense the measured variable, and then it is going to provide it to the further elements of the measurement system. Now the primary sensing element, because it is first measuring the measurand, means the measured variable. So the output of the primary sensing element, it can be a non-electrical quantity or it can be an electrical quantity. Non-electrical quantity like the strain, pressure, force, these are all non-electrical quantity. And electrical quantity like voltage, current, and the rectifier, or these are the primary sensing element where the output is an electrical quantity. Now, when the output of the primary sensing element is a non-electrical quantity, so it has to be converted into an electrical quantity, and this operation is performed by a transducer. Transducer is a device which converts a non-electrical quantity into an electrical quantity. So, if output of primary sensing element is non-electrical quantity, so it is converted into an electrical quantity by a transducer, because the other parts or the other functional elements of the measurement system, it may be possible that they deal with the electrical quantity only. So non-electrical quantity, it has to be converted into electrical quantity by a transducer. So we can say that the first stage of the measurement system is the detector transducer stage. The detector, that is the sensor, it is going to sense the physical quantity or the quantity which we want to measure, and that quantity is converted into electrical quantity by the transducer. So first stage is the detector transducer stage. So in the block diagram, we see that the quantity measured, it is sensed or measured by the primary sensing element, and then primary sensing element is connected to the variable conversion element. So that electrical output is going to be provided to as an input to the variable conversion element. So second functional element is the variable conversion element. Now, when the primary sensing element, the transducer, it is converting the non-electrical quantity into an electrical quantity. So that output, it may be a voltage, it may be a current, or it may be a frequency. And this electrical output, it may not be accepted by the other stages or other elements of the measurement system. So this variable conversion element, it converts the output of the primary sensing element into a form that is accepted to other elements of the system. Okay, so conversion is done here, that is why it is variable conversion element. Now, example of variable conversion element is like, suppose the output of the primary sensing element after conversion, like after converting into an electrical quantity, suppose the input is in the form of analog signal, but the other elements of the measurement system, they accepts a digital input. So this analog signal, it has to be converted into a digital signal. So we have to use an A to D converter here, that is analog to digital converter, which is going to convert the analog input to the digital output. So here, this is an example of the variable conversion element. Now, due to this conversion, the information content of the signal, it is not destroyed. So you have to convert, this element is going to convert the signal from analog to digital form, but the information content is retained in the signal. So no damage is done, no information is lost from the signal due to this conversion. So in the block diagram, here the variable conversion element, it is converting the signal into a form which is acceptable to the other elements. Okay. Now comes the variable manipulation element. Now, there are sometimes necessary to change the level of the signal. Like if the signal is having very low amplitude and we want that the signal should have a high amplitude, so we want to amplify the signal. Okay. Also, if we want that if the signal is having some disturbance or noise in it, so we want to remove the noise from it. So filtration has to be done. Okay. Also, if we want that if we want to have the modulation or some differentiation or integration has to be performed on the signal, so that is done by the variable manipulation element. This element, it manipulates the signal without destroying the information contained in the signal. Like if we want to amplify, we can use an amplifier here, and this amplifier is going to change the amplitude of the signal. So the variable manipulation elements, they only manipulates the signal without destroying the information content, so that it is accepted by the other components of the measurement system. Next functional element is the data transmission element. The data transmission elements, they transmit the data or the measured variables in between different components of the system. Suppose we want to like if the in the case of satellites, the controller station or the control station of the satellite, it is on the earth, and the satellites, they are in the space. So if we want to transmit some data from the earth to the satellites, so we have to use a transmitting medium in between. So the data transmission elements, they transmit the data from one element to other element of the system. So data transmission elements are required to transmit the data containing the information of the signal from one system to another. An example is like satellites, they are physically separated from the earth. So we have the control stations, and these control stations transmit the data from the earth to the satellites by sending commands to them. Okay. Now, in the block diagram, after the data transmission element, the data, it can be directly given to the data presentation element, or it can be given to the data processing elements. So, the data processing elements, they further process the data. That means if like further amplification or further modification of the signal is required, that is done by the data processing element. So after processing, the signal is given to again the data presentation elements. Will these elements, they convert the data into a presentable form, so that the observer, it can read the value of the measured quantity. Okay, so maybe it can be given in the form of direct readings, or in the form of a digital output it can be given, or in the form of a recording or print of the paper. In the form of that, it is given to the observer, so that the observer can easily read the readings. Okay, so next, the function of the data presentation element. So this data presentation element, its function is to provide an indication or recording in a form which can be evaluated by an unaided human sense or by a controller. So these data presentation element, it may involve the display devices. The display devices, they will directly display the readings on it, or it may involve the indicating devices which indicates the reading with the help of a pointer on a scale, and in the form of recording also, like recording the values over a paper. So the paper is also a type of presentation element, display device, and these recordings or the output of this data presentation element, it can be easily read out by the observer. So its function is to convert it into a readable form. Okay, so these are the different elements, functional elements of a generalized measurement system. Now let's have a look over a flow chart which describes all the stages of the measurement system. So these are the different stages of the measurement system. In the first stage, what the primary sensing element does, it senses the desired input and provides the analogous output. So that is done by the first element, primary sensing element, stage 1, which is the detector transducer stage. So detector is going to detect the unknown quantity and transducer is going to convert it into an analogous output or an electrical output. Now the second stage, it consists of three things. In the first stage, the first step is to modify the transduced signal into a form which is usable by the final stage. So that is done by the variable conversion element. The conversion element is going to convert the signal into a form which is acceptable to the other elements of the system. Then the variable manipulation element. This manipulation element, it is going to increase the amplitude or the power of the signal according to the requirement. If we want that the low amplitude signal is converted into a high amplitude signal, so that is done by the variable manipulation element. Then comes the selectively filters the unwanted components and convert the signal into pulsed form. So that is the processing element which is going to further process the signal. Like if we want to remove the unwanted signal or disturbances or noise from the signal, so it is going to filter out the unwanted components and convert it into a pure signal or a pulsed form signal. Now next we have provides an indication or recording in a form which can be evaluated by some personal or some display devices or some computers. Okay, so this is done by the data presentation element which are going to convert the data into some presentable or readable form, and then the data is recorded digitally on a computer if it is necessary. So this is the stage 3. So these are the different stages of a measurement system. Now let's take an example of a measurement system and let's see that what are the different elements in that measurement system. Here we are taking an example where we are measuring where we are using the Bourdon tube, and this Bourdon tube is used to measure the pressure. So pressure is the input or the quantity which we want to measure. So this pressure is given to the primary sensing element, and this primary sensing element is going to convert it into a force. Then we have the variable conversion element which will convert this force into the displacement. So both these function, primary sensing element and variable conversion element, it is done by the Bourdon tube. In Bourdon tube, we have the structure of a Bourdon tube is like this. Okay, here we apply the pressure in it. So due to that pressure, a force is generated, and due to that force the displacement occurs. Means the shape of the Bourdon tube, it is a C-shaped Bourdon tube, so it is of like this type, and when pressure is given, due to the force of that pressure the displacement occurs, the shape of the Bourdon tube it changes. Okay, so here pressure is first converted into force, and then force is converted into displacement. After that, this displacement is given to the data transmission element. Through the Bourdon tube, a gearing mechanism is attached, and due to the displacement occurring in the Borden tube, the gearing mechanism, it rotates, and through the gearing mechanism a pointer is attached, and this pointer is going to deflect over the scale. So the pressure in the Borden tube, it is converted into the displacement, and this displacement can be measured with the help of the pointer displacement or pointer deflection over the scale. So here the data transmission element is the mechanical linkage, which is connecting the Borden tube with the pointer, okay, with the gearing mechanism. So here we have the variable manipulation element, and in this mechanism we have the variable manipulation element as the gearing arrangement. So mechanical linkage, it is transmitting the data between the Borden tube and the gearing arrangement, and the gearing arrangement is amplifying the displacement and converting it into the, or providing it to the data presentation element, which is the pointer. And this pointer is moving over the scale, and observer can read this scale so that it can measure the displacement. Okay, so in this whole mechanism, Borden tube is acting as both the primary sensing element and variable conversion element. The mechanical linkage is acting as the data transmission element. The gearing arrangement is acting as the variable manipulation element, and pointer is acting as the data presentation element. So this is how the complete pressure measurement system, it is described. The various functional elements are mentioned over here. Okay, so this is an example of a pressure measurement system. So in this video, we studied about the different elements of a generalized measurement system. What is a measurement system? What are the various functional elements? And then we studied the function of those elements. And then in the last, we studied an example of a pressure measurement system. So I hope that this topic, elements of a generalized measurement system, is clear to you. Thank you.